Hi to all students. Today we continue with another subtopic or subpart of the stoichiometry is known as balancing redox equation. Balancing redox equation. Okay, we look at example 2. Redox equation means oxidation and a reduction process occurs simultaneously. Simultaneously. I'm quite sure students have heard this term during the upper secondary school. The term that known as oxidation and reduction. Oxidation and reduction. So in this case, we have to, as a first step, we have to split the overall equation given, this equation, into oxidation equation and reduction equation. So therefore, we have to find the oxidation number to determine which one undergoes oxidation or which ion undergoes reduction. So it must be either one of these undergoes reduction and the other one oxidation. So for example, I take Cr2O7 to negative, 2Cr plus 7 oxygen is negative 2. 2Cr plus 7 oxidation number is negative 2. So it's negative 2. So 2Cr equals to positive 12 and Cr equals to positive 6. So the oxidation number of Cr here is positive 6 and here is positive 3. So that shows a reduction. That means chloride ion to chlorine must be an oxidation. So the first step, as I mentioned earlier, we split the equation into two. One is oxidation, Cl minus 2, Cl2. The other one is reduction, Cr2, O7 to negative 2, Cr3 plus. That is the first step. The second step, we have to balance other element than oxygen and hydrogen. So in the case of oxidation, the other element is chlorine. So students can see here, there is one chlorine here and there is 2 chlorine over here. So to balance the equation, we have to add 2 chloride ion, Cl2. Now the chlorine is balanced. Similarly, for reduction, students can see 2 chromium ion here and there's only 1 chromium ion here. Only 1 chromium ion. So to balance the equation, Cr2, O7 to negative to 2Cr3 plus to balance the chromium ion or chromium atom other than oxygen and hydrogen. Now we go to the third step. Now the third step is balancing oxygen by adding water. Balancing oxygen by adding water. Since oxidation do not contain any oxygen atom, so we rewrite again as the same one based on previous step 2. As for reduction, students can see there are 7 oxygen on the left hand side. So meaning to say Cr2O7 to negative 2 Cr3 plus, I have to add 7 water on the right hand side. Why this is so? Because there are 7 oxygen here and there should be a 7 oxygen over there. The next step, step number 4, that is balance hydrogen ion by adding ion hydrogen or proton. We call ion hydrogen. Okay. This is also similar for the oxidation where there is no oxygen and there is no hydrogen. So we write as it is from step number 3. As for reduction, we can see there is 14 hydrogen on the right hand side. So we need 14 hydrogen on the left hand side. Okay. Cr2O7 2 negative plus 14 ion hydrogen. 2Cr3 plus 7 water. Why I add 14 hydrogen ion? Because there are 14 hydrogen on the right hand side. Next step, step number 5, that is balance charge by adding electron. So let us see on the oxidation. 2Cl negative to Cl2. The charge over here is, the charge over here is 0, while the charge over here is negative 2. The difference is 2, and the 2 must be added. The 2 here refers to 2 electron must be added to the most positive side. More positive side. So I add 2 electron over here. Therefore, the oxidation equation is automatically balanced. Now, we try to do the similar for reduction. Cr2O7 2 negative, 14H plus, 2Cr3 plus, 7H2O. Here is negative 2, here is positive 14, and the difference here is positive 12. Here is positive 6 and here 0. The difference here is positive 6. Positive 12 and positive 6 on the opposite direction. So the difference here is 6. And 6 add to the most positive side, a more positive side, that is here. So the conclusion equation for the reduction will be Cr2O7 2 negative plus 14H plus 6 electron, 2Cr3 plus 7 H2O. This will be the reduction. Now we come to step 6. That is rewriting back the equations and cancelling off the electron. Oxidation first. 2Cl negative, 2Cl2 plus 2 electron. Reduction. Cr2O7 2 negative, 14H plus, 6 electron, 2Cr3 plus 7 H2O. However, the electrons here is not balanced. You can see for the oxidation 2 electron, for the reduction 6 electron. Therefore, we have to multiply the oxidation equation by 3 to turn this one into 6, this into 3, this into 6. Okay, so then we can cancel. We can cancel these two. So the overall equation now will be Cr2O7 2 negative plus 14H plus 6Cl negative produces 2Cr3 plus 7H2O plus 3Cl2. This is called balancing a redox equation using ion electron method, and this is specifically for acidic medium.